Hi, my name is Joel Keeney, and we will be going over my volumes unit plan today. In my volumes unit plan, we will be going over standards and objectives, activities, technology, assessments, and one of the lesson plans for that full unit. Here we have our unit plan for our volume unit. At the top, we have our unit title. We have the grade and subject that we would be in. This would just be an 8th grade math class. The reason I put subject 3 or unit 3 is it aligned with some standards that were 8.3. And then we also have our dates. Hopefully we should be done in that many days. Here's our standards. These came directly off the Nebraska Content Area Standards website. And that can be seen for anybody. You don't have to have special access. And then our objectives are what the students will be able to do. Down here we have our essential questions. These questions are questions that I want students thinking about every day when they're in the class, every day when they're in that unit. Where will we use this in our real life? Can I use this in any of my other coursework? And are there standards of measurement, inches, meters? Are we using metric or are we not using metric? That one is specific to this unit. The other two are probably going to be essential questions that are used throughout the year. Stage 2, we have create an assessment. How are we going to create assessment? We're going to make sure each unit standard is assessed. We're going to make sure all our questions or tasks are aligned to a standard. We're going to make sure that the assessment incorporates real-world application and that students are required to address the essential questions and proficiency is clearly identified for each measurement or question. Our proficiency is right here in our unit goals. 80% of students will get 90% on their daily quizzes. 100% of students will complete homework assignments. 80% of students will get 80% on the unit exam. And 80% of students will get 90% on their performance task. If we can achieve those unit goals, hopefully I have done my job. And then down here, stage 3 is our sequence objectives. Really just a fancy term for here is our calendar. Here is how we are going to be able to achieve our unit goals. Day 1, that's our intro to our unit and our goal setting. Intro to our unit, I have a warm-up question that I will show you later on in this presentation that hopefully can kind of give me an understanding of what these students already know about shapes. What do we need to learn about shapes? Where are we coming up a little short? And then we are going to get into our unit terminology and give them a vocabulary homework assignment. That can be either individual or group, depending on what I'm feeling that day. I like group work, so a lot of my work is going to be group work. I think it's beneficial for students. Day 2, we're going to review our vocabulary homework. Just a quick review of it. If anybody had any questions, if they didn't understand something, just kind of get into that. And then we are going to review areas and perimeters. At this stage, students should have a decent understanding of areas and perimeters. A gentle reminder is really all I'm going for in that review. And then we will begin our surface area homework. Day 3, review any questions that we may have had over our surface area homework, and then get into our cube and prism volume. And then our homework for that day will just be all word problems, all real life examples of where we would see cube and prisms and why we might need to know their volumes. And then our exit ticket that day is going to be a surface area exit ticket. I don't want to do the surface area exit ticket the day we do surface area. I want to see if my students are retaining any of that information. So putting it a day later can help me see if we're actually having retention. And then day 4, that's our prism volume warm-up. Like I said, that's a day later. Are we retaining any information? and then getting into our cylinder volume and our cylinder volume task cards. The task cards are an individual activity on Socrative, and that's how I'm going to incorporate technology into this unit, is using a lot of Socrative. I like that website. I think it was very informative. And then day 5 as a group. Day 5 is all group work. The whole day, everything we're doing is going to be group work, and we are going to review our task cards from the day before, and we are going to start on our cone volume and our cone volume team task cards. Day 6, our volume relationship warm up. We're really going to see if we're seeing those relationships between different volumes and how they relate to each other. And then we're getting to our sphere volume and our sphere volume task cards, also on Socrative. Day 7, we'll have a composite volume warm up, as we've looked at all of them. We've had cylinders, cubes and prisms, cones, spheres. Those are the shapes that we use to build composite shapes, or we may have to subtract one of those for our composite shape. And then we're getting into our ice cream activity, which is an activity that I'll show you later on, and a missing measurement exit ticket. Day 8, we begin our performance task, and that I have a little example of later. Day 9, we're putting our finishing touches on that, and we're beginning our review. It's a team task. Day 10, we're finishing that team task. We're reviewing our team task as a class. We're going over any questions that we may have over this entire unit. And at the end of day 10, given a description of what the students should expect to see on our unit exam. Day 11, there's our unit exam. If the students are achieving pretty well, days 8, 9, and 10 may be condensed down into 2 days as opposed to using all 3. It just depends on what we're seeing out of the students and how they are doing in that particular unit. Here's our learning goals for that, just a more in-depth view of our learning goals. So our standards, like I said, this comes directly off the Nebraska Content Area Standards website. 831, students will identify and describe geometric characteristics of two-dimensional shapes. What does that mean for the students? That's where I'm getting our aligned objectives, really giving them a smaller task that we can do that will fit into that standard. And that would be, students will be able to define different two-dimensional shapes. Students will be able to identify the differences between different shapes. 833, students will perform and compare measurements and apply formulas. That means students will be able to measure different objects using multiple units of measurement. Students will be able to identify the formula needed to solve real-world problems. Students will be able to identify relationships of different volumes. 833b, students will apply the Pythagorean theorem to find side lengths of triangles and to solve real-world problems. Students will be able to identify the missing measurement of a triangle, and those other standards are lower on. Here is a fill-in-the-blank assessment. This could be used as our vocabulary homework. This could be used as a section in our summative assessment at the end of the year. It's just a little fill-in-the-blank that I have created, and I could use that at any time. I have formulas up there, I have some degree angles up there, and then just a lot of our vocabulary that we would be using in this unit. And then here's that performance task that I alluded to earlier. Use a digital presentation tool, PowerPoint, Google Slides, Prezi, something like that, to design a volume presentation. This presentation will include 4 different shapes. 2 of these shapes must be composite shapes. These shapes will be found in your everyday lives. I want students to find shapes in their own home that are composite shapes. And we will be taking measurements of those shapes and calculating the surface area and the volume of each. I want them to do both of those, surface area and volume. The presentation must include a picture of each shape and the measurements of each shape and the work used for your calculations. Um, I have a little point assessment down there, how it's going to be graded. I will also give the students examples for that. And then I want them to ask me any questions that they may have over this. And I won't know if they're measuring it accurately just based on the shape unless they include like a ruler in their picture, but I would be able to check their work for their calculations. Now here's the warm-up. The intro to this unit is what I'm going to start this warm-up with. Draw a shape with its length equal to its width. Hopefully most students will draw a square. Draw a shape with a radius of 5. Hopefully most students would draw a circle. All right, then we have our bonus one, which is really leading into this unit. Draw a shape with its height equal to its radius. I'm not sure if a lot of students will be able to get that without having gone through this volume unit. I presented this to my college classmates, and they were not able to come up with a cylinder. So if they're not in that, they might not understand it. And then here's the relationship exit ticket. What is the relationship between the volume of a cylinder and a cone? Okay, if we've gone through our volumes, I would hope my students would understand that the cylinder is 3 times the volume of a cone as long as they have the same height. If we haven't gone through those two, I wouldn't expect anybody to get that. But once we do that exit ticket, then the next day we can actually visualize it. Then our ice cream activity. I talked about this earlier. We will be making a poster comparing volumes of different shapes of ice cream. The poster will be divided into 4 sections. The sections will include a title section, a cup section, cone section, and scoop section. Each section will include a drawing. So the cup, you'll have a cylinder. The cone, you'll obviously have a cone. The scoop, you'll have a sphere. And then I also want those measurements. And then on the back of the poster, I'll have given them different price points, and I want them to tell me which one is the better value based on their calculations of the volumes. This can, who doesn't like ice cream? And then here I have my links to my Socrative activities. I will show more in depth the links later on. These have my 2 group work activities. It also has my 2 individual task activities. And yeah, I'll get into more in depth on those later on. I have another slide where we actually kind of see what the task cards will look like for the students. Now I want to show you a little bit about my assessments. My assessments are not going to include all of the questions that I'll show you, but it will be different pieces of it. I mean, it could be all of it, but I wouldn't expect my students to be able to complete all these questions in one class period. So I have some multiple choice, just shape identification, define different characteristics of shapes, going over the faces, the vertices, the edges, seeing those different things, some of the units. Then I have where we're actually going to do some calculations. My students would have a scratch sheet of paper, or they could just write their work off to the side on each one. Then down here, I have volume or surface area. Okay, look at these formulas. Tell me, are they related to volume? Are they related to surface area? Obviously right here, they wouldn't be 2 different colors when I give them to the students. I think that would confuse them even if they're not the 2 different ones. I think that's going to make a student want to say, okay, the dark ones are volume, or light ones are surface area, and just go right through like that. So they would be the same color. True or false? Circle true, circle false. If it's false, change it to make it true. Pretty self-explanatory. I wanted to give them that T and F because sometimes when you write T or F, it can be confusing and I might not understand what they were actually trying to write. Have some basic matching. Match the shape to its name. Nothing too crazy there. And then our constructed response. We always like to get literacy into our math classes. So have some essay questions here. Like I said, these wouldn't all be on there, but I would definitely do at least 2. We really want to get our students writing in the math class. I have a description there, short paragraph. What's a short paragraph? 3 to 5 cents. That's what I expect. Down here, short answer. What's a short answer? 1 concise sentence. That's all I need. That's all I want. You can give me 1 sentence. That will be enough for me. Down here we have some questions that get a little more work involved. We have some of the relationships. Number 10, I really like number 10. A cylinder, a sphere, and a cone all have the same radius of 9 centimeters. The heights of all 3 shapes are the same. What is the height of the cylinder? That's a thinker for some. Hopefully my class would be able to do it. And then number 12, I would want my students to draw me a picture. Draw a picture of that. Show me that you're really understanding what is being asked. Then I have another review here. Possibly if we needed another day of review, here's a quizzes that we can go out and take, and that can help shore up any areas that the students may not be understanding yet, any areas where I feel that we need extra support, any extra help like that. So here is a little bit of one of the Socrative links. This, I believe, is one of the individual tasks. Yes, it is one of the individual tasks. The picture on the right is what the students are going to see. And let's have them solve it. That's really all it is. In section 1, we'll set this up, solve the problem, round it to the nearest whole number. That's it. Fairly straightforward. That's all these are. Straightforward. Read it, set it up, solve it. Yeah. Number 5. A cylinder has a radius of 5 meters. The volume of the cylinder is 1021.02 cubic meters. What is the approximate height of the cylinder? Hopefully my students can solve that fairly easily. This would be done, and then we would review it as a group the following day. So here is my lesson plan that I included. This lesson would happen on day 2 of our schedule. It would happen directly after our vocabulary, so hopefully we can remember radius, height, length, width, all those words that we would be using in our formulas. I'd begin the class with just a quick question of what do we remember about area? Some of them may know a lot, some may not remember a lot. This is a little pre-assessment of how in-depth do I need to get in this area? How many of our problems do we need to go through as a class? Can we just kind of skim over this and get through the area and surface area day quickly, or do we need to spend quite a bit of time? Once we kind of get our thoughts flowing about what we remember about area, then I can ask them, how can we apply this to 3D shapes? Can we use any of those formulas to help us solve any problems with 3D shape? I don't want to give them too much away about surface area, as that's the whole day. If they can come up with that relationship of surface area being just the addition of all the surfaces, the total surface area of that shape, then that's great. I would not give them that answer yet. And in this anticipatory set or hook to get us started. It may not get the students going, and I could give them little reminders of what we remember about area. What are some formulas that we may know? How can we use a radius to help find an area? Little gentle nudges like that. And then in my activities, it says handout notes packet. I would like to already have that handed out since this is day 2, but some students may not have it. Some students may want to leave it in my classroom. That would always be an option. So handing out the packets, that's what that means. The students would begin filling out the notes packet based on what they think they already know, and what we would be going over in our discussion about what do we remember and how can we apply it. Then I would start this video. I have one video that is just area, so really it's just going to be a review video. Hopefully all the students already have seen area and it's just a review. Then I have a surface area video where students will see how we're getting the surface area. We're just adding areas of all the surfaces. So this is why we need to know what formulas we need for area. While we're watching these videos, there will be notes that students will be filling in. There will be little blanks for some of the key terms, some of the key formulas that these students will need to know, and they'll be filling these out as the videos are going. And if I need to have special accommodations, some of these blanks may already be filled in. I may pause the video when they highlight something or when we need to be writing something in our notes. And then after we've gone over that and we've understood that surface area is just areas being added, I'm going to hand out the homework. If I need to, we can do a few of these problems together in class. If I don't need to, we might not. We may shorten the homework. It just depends on how that class is going, what this class looks like they're understanding. Do we need to shorten it? Do we need to really look at these problems in depth, or can they just do this on their own? And that's really that day's lesson. Watching 2 videos, really getting a class discussion going about area and how it can build into surface area and how they relate to 3D shapes. Hopefully, my students will have that figured out by that day. And then day 3, we would start working on our volumes. Thank you.